In this video, we're just going to talk about ionic compounds, only the first type of ionic, so type 1 ionic compounds. So ionic compounds always involve a metal and a non-metal, and they have what we also call a cation or an anion. Remember that a cation is just a fancy way of saying metal, right? An anion is just a fancy way of saying non-metal. There's always something from the left side of the staircase and something from the right side of the staircase. So here's the staircase in our periodic table. Write all the anions, or the negative ones, or the non-metals are all over here, and all the cations are always over here, and they're positive, and they're metals. Type 1 ionic compounds are only going to involve ones that have one possible charge. So I put down some examples like calcium, 2 positive, sodium, and aluminum. For some reason it doesn't want to convert these into superscript, where it should be up here, not right beside it. So I'm going to show you a periodic table of ions after, just so we can pick out which ones would be type 1 ionic. So this is your table of ions that you have at home, right? So any of these ones, again, first on the left side of here, so any of these over here we want to be looking at. So when you come upon a compound, if it's the name, then you want to search for it on here. If it's the symbol, again, you want to search for it on here. To see whether or not it fits our type 1, we always want it to have boxes that look like this, or this, or this. We don't want it to have any of the boxes that look like this. So it can't be these ones. These ones that are split in two, those are for type 2. So we're only going to be worried about these ones right now that are type 1. So let's do some examples, and so let's look at the cation. So the best thing to do is look at the cation first and write out the name just as you find it on the table of elements. So this one, I wrote that because we want to make sure that we keep the name the same. So when I look on the element side of the table, it says calcium, then I write calcium. Okay, and then I'm going to look for oxygen, or the O, and you can either do it two ways. You can know that O is for oxygen, but then you have to remember that the ending changes from EN to IDE, so it's oxide now. Or you can simply just look on your table of, ions and see that it's going to be calcium oxide. Okay, this one I'm going to check and make sure, is it actually type 1 ionic. So Mg is magnesium. I find magnesium has an atomic number 12, so that's in the very first or second row there. So magnesium, when I look at magnesium's box, I see that magnesium is only one possible charge, right? Magnesium's box looks like this, only like that. Not split in two, only one possible charge. So this is definitely type 1 ionic. This is a cation, right? This is a metal, so it is written first. The next one is Br. So when I look for Br on my table of ions, I see that Br is bromide. So I write magnesium bromide. Okay, let's go down to here. So this is supposed to be AlCl3. So Al, and if I'm going too fast, you might want to pause it first and then try them before you hear me say the answers too. So Al is for aluminum. Okay, and aluminum only has one possible charge, right? Again, aluminum's box looks like this. It's got the number 13 in the corner. So aluminum, and Cl is for chlorine or chloride when it becomes attached to there, so it ends in IDE. Okay, last one is Ba. So Ba I'm going to find is barium. I'm I'm going to look for S, and it's called sulfide. So it's called barium sulfide. So again, first thing we want to do to make sure that it is type 1 ionic is you always want to look at the cation. So that's always going to be this first thing that's written. You always want to make sure that that cation only has one possible charge, so the box is not split in two. And then the second thing that we're going to do is we're going to look at the anion and figure out what it's going to be called as an anion, so the ending changing to IDE. So next we're going to try some where we have the name and we're going to go to the formula. Oh, I think I was going to do some with some polyatomics first. So here is the polyatomic list that you find at the top of your table of ions, just so you know what I'm talking about when I say polyatomics. Remember that poly means many, and this is about many atoms altogether. So when you see something weird like, let's say, LISCN, this doesn't mean lithium, then sulfur, then carbon, then nitrogen. Anything weird that you don't really recognize or you think, what the heck is that? It's probably something that you're going to find on this periodic table of polyatomics. So you want to look for this SCN, which is thiocyanate. Oh my goodness. So let's try the next. Okay, so we have Al2. It's supposed to look like this. Cr2O7, with brackets around it with a 3. So I'm going to look up what Al is and make sure that it's a type 1 ionic. And I can see that it is aluminum. And again, if you want to pause the video here, you could pause it and then come back to it and see whether or not you get the same answers as I do. Now this I don't recognize, right? So this I'm going to go and look for in the polyatomic chart. So when I look for this on the polyatomic chart, I see that this is called dichromate. So it's aluminum dichromate is what this is called. Okay, next I see this one. So GaNO2, and so it's supposed to look like this. Okay, so Ga I'm going to have to find. And I see that Ga is gallium. Okay, NO2 is not going to be then nitrogen and then oxide. I'm going to look for NO2 on my polyatomic chart. So I see that polyatomic chart says that NO2 is called nitrite. Like this. Okay, next is this one. So first I'm going to find this cation, make sure that it only has one possible charge, so it is barium. Then I'm going to look for HSO4. So HSO4 is actually hydrogen sulfate, it's called. So it's going to be barium hydrogen sulfate. This one, so again we have Ga, so that's gallium. MnNO4, I'm going to see is actually called permanganate. Like so. You can recognize that things come from the polyatomic if you're working backwards. So if you had the name, for instance, and you had to work backwards to the formula, you can recognize polyatomics because of this. They end in always ITE or ATE. You'll notice that the ending is different than the regular IDE. So those are kind of hints that it's on the polyatomic chart. So next we're going to try ones that have the name, and we're going to go to the formula. So here's a couple. So this one is lithium nitride. So how I do this is I go and look for lithium on my periodic table of ions. I see that lithium is normally just one positive. Okay, I'm gonna go look for nitride, which is actually nitrogen, right? As an ion. So they go like this. Okay, now what happens is that this positive would go down here, and this 3 would go here. So I'm going to write it like this. I'm going to write Li3N. I don't actually like write in a 1 here because that looks all funny, right? So I don't actually write in a 1 here because that looks funny. And I just want to show you why we actually get that. So this 3, when it looks like this now, actually tells me that I have 3 of these lithiums, right? And we said that each of the lithiums was 1 positive. So here's 1 lithium, here's another lithium, here's another lithium. Now here, this tells me that I only have 1 nitrogen. Each nitrogen is 3 negative. Do you notice that if I have 3 positive plus 3 negative, I get 0 as a final charge. Remember that compounds have no charge on them, so I shouldn't have any charge after. So that's actually why we switch the numbers around, just so that you don't think it's magic and I'm just magically switching the numbers around. Okay, let's try it with barium iodide. So barium I'm going to look up, and I'm going to see that it's 2 positive. Iodine I'm going to look up, and I'm going to see that it's negative. Okay, so that means that the 2 is going to go down here. So I write BaI2. Okay, this one just has a 1, right? And so I don't really write the 1 in here. Again, that looks funny. So I don't write it in there. Okay, let's try some more. Okay, how about calcium chloride? So again, if you want to pause it and see if you can do it yourself, you can try that. But calcium is 2 positive, chlorine is negative, so the 2 is going to go down here, the 1 would go here even though we don't write it, right? It would be CaCl2. Okay, and then calcium sulfide. So again, calcium is 2 positive, sulfur is 2 negative. They are both exactly the same, right? One's just positive and one's negative, so therefore they cancel each other off. So we write CaS, like so. So no extra numbers. Not this. That's actually wrong, right? We cancel off the numbers and get just CaS. Okay, and now we're going to try some with some polyatomics in it. So sodium carbonate. I recognize first off that they have polyatomics because one is carbonate. So sodium is positive. Carbonate, when I look at that little box at the top, I'll see that carbonate is CO3 to negative. Okay, now when they go together, I'm going to write Na2CO3. The 2 is going to go down here. The 1 from here is going to go over here, but we don't actually write 1, so it'd be Na2CO3. Okay, next one is calcium hydroxide. So calcium is 2 positive. Hydroxide ends in ID, but it's actually not on the regular periodic table of ions. You're going to have to look at the polyatomics to find hydroxide. Now when these 2 go together, you'll see that the 2 is going to go down here. I'm going to show you that you do not write it like this. So this is wrong, because right now this looks like I have 2 hydrogens, but that doesn't mean that I have 2 oxygens. So it just tells me that I have 2 hydrogens. So this is actually wrong. What I actually need to do when I do this is to say that I have 2 of the hydroxide group, so I need to put these brackets in. And put a 2 here. Now the only way I put the brackets in is if I'm having to put an extra number here. What will happen is sometimes I show people brackets and then they get what I call bracket happy, and then you guys will put brackets like around this one that we did before, even though you don't need brackets for this. So I'll say I might write something like you're bracket happy, because brackets actually aren't needed there. Okay? 2 more. So zinc sulfate and aluminum acetate. So try and see if you can do these ones on your own. So you might want to pause it first and then see if you can do it. So zinc is 2 positive. Sulfate you'll see is SO4 2 negative. And when they go together, because they're both 2 positive and 2 negative, there's no extra numbers, right? So it just is zinc SO4, because these would cancel each other off. Okay, next is aluminum, which is 3 positive, and acetate, CH3COO negative. Okay, so now, do you think I write it like this? The answer is no, right? The thing I'm missing here is I need to have these brackets in here to say that I have 3 of these acetate molecules, not just 3 oxygens. Okay, if for instance I did need to count out, let's even start with this one, how many zincs are in this molecule? There's 1 zinc. If I ask you how many sulfurs are here, there's 1 sulfur. If I ask you how many oxygens are in it, there's 4 oxygen. We'll do the same thing down here. So if I ask you how many aluminums are in there, there's 1 aluminum. If I ask you how many carbons in there, this is kind of tricky because we have to do this. We have to do 3 times this carbon and 3 times this carbon. So that's 6 carbons altogether. If I ask you how many hydrogens there are, that would be 3 times 3. So that's actually 9 hydrogens. If I ask you how many oxygens there are, that's 3 times this one and 3 times this one, so again that's 6 oxygens. Just so if I have to do the molar mass of something or the molecular weight of something, I need to know how many are in each one. Okay, so hopefully that helps you figure out how to do some naming, so at least you can get started. I'm gonna be available for extra help, so if you need to come see me, don't feel scared to come say, hey, I don't get this, so come sit with me. Good luck with your homework.